Hello and welcome back. So in this video we're going to be talking again about the compound interest formula and why it's important to avoid rounding errors. Okay, it's a thing that I see happen quite often in students working and it's a really easy thing to avoid. You just have to use your calculator's memory function. So we're going to have a little bit of a play with this and just understand. Okay, so this is a relatively straightforward compound interest question, okay? We're actually going to dive into this and I'm going to tell you my tip and I'm going to tell you what happens if you don't follow it and you actually do some rounding early on in the question, okay? So first off, it says Mr. Williams invests $7,500 in a saving account for 7 years at 2.5% per annum. The interest is compounded monthly. What is the future value of this account? All right, now this just means what is the final value in the account at the end of the 7 years, okay? So first things first, it's compounded, so we know we are using the compound interest formula, okay? That's this thing that we've established earlier on. So what we need to do is we need to establish the principal. Well, that's just $7,500, okay? We need to establish the interest rate. Now the interest rate is 2.5% per annum, okay? This can get a little bit tricky when you have interest rates that don't simplify down into nice numbers. Like our last video, right? We had 12%, it was simplified down monthly just by dividing by 12. Well, again, because we're compounding monthly, we need to break this whole thing up across a year into months. Now, when I do 2.5% divided by 12, it doesn't actually give us a nice decimal. So just watch what I'm going to do here. Okay, so first things first, I'm going to divide this number by 12 at some stage in this calculation. I really want to show you this first. Okay, I'm going to first write this as a decimal. This is equal to 0.025. That is what that is equal to as a decimal. When we then apply the division by 12 to break it down from across the year into each month, okay, dividing by 12, our interest rate that we end up with R is equal to a horrific decimal. So just watch this. If I do 0.025 equals divide by 12, we end up with a horrific fraction to begin with, but let's just put this in here for a moment. We end up with this horrific decimal that is actually a repeater afterwards, okay? And what this does is if I was, say, to round to three decimal places, 0.002, we're going to call it a rounding error. So what I like to do in these particular cases is I like to store this value as a fraction in my calculations when I'm actually doing my answer. So I'll show you how we do that here. Okay, so 0.025, I'm going to write this in blue as a fraction. That's just 0.025 over 12. Okay, just like normal, except I'm just writing this as a fraction to help us out. Last thing I'll do is I calculate my end value. We've decreased this by a factor of 12, all right, which means if we're in there for 7 years, 12 months each year, it's going to be 7 times 12. So this is decreased by a factor of 12. That means our compounding periods are increased by a factor of 12. All right, and 7 times 12 just gives us 84. Okay, plugging all of this into the formula, you'll see how I approach this. Okay, our future value that we're calculating, again, just like before, we replace the P with 7,500. 1 plus our interest rate, 0.025 over 12, all to the power of our compounding periods. Okay, rather than straight away entering this in as it is on here, I like to do a little bit of simplification with the calculator. I like to just go 1 plus 0.025 over 12, just to avoid any sort of issues that may happen with my calculator happening and, you know, user enter error and all of that sort of stuff. Okay, and I keep that fraction, you'll notice, stored in my calculator. Okay, now what I then do to avoid any rounding errors that may occur, okay, is I then clear the memory and I go answer, I get my power and I do the power next to the power of 84 equals, that gives me 1.19. Okay, I can either choose to clear again using the AC button, never the on button, because that clears the memory of the entire calculator, all right, and then multiply by 7,500, or I can just multiply by 7,500 off the bat, and it stores all of my answer inside of a calculator, okay? That avoids any rounding error that we actually have occurring. And you'll notice our final amount at the end of the 7 years is $8,000. 932 and 72 cents going to 2DP. However, let's say instead that we do decide to use our rounded value that we had sort of discovered before. Okay, so we keep everything the same, but we change our interest value, right? Remember I told you if we ended up with 0.025 divided by 12, we ended up with this decimal. I'm going to round it to 3DP, and let's just watch how this sort of changes our answer. Okay, so 0.002, I'm going to plug this value into the formula instead. So same thing, everything else is the same. So A is equal to our principal, 7,501, plus our rounded interest rate, 0.002, all to the power of 84. If we plug this value into our calculator, all right, the same thing as before, so 1 plus 0.002 equals, we're then going to bring that to our power of 84, so answer to the power of 84 equals, and then we're going to multiply, just like last time, by 7,500. Okay, what I've done is I now have a different answer, 8,870.54 to 2DP. Okay, and there is a problem with this different answer, okay, because this is now an answer that's been generated off of a rounding error. This is the answer that we should have because we haven't introduced the opportunity to have any rounding errors. So let me just explain this, right? We've stored each answer as an exact value in our calculator at each step, and that has eliminated the rounding errors that can occur while we're doing this particular question, okay? This here is just an example of one rounding error that can occur. And you'll notice the reason why this occurs is because this rounding of a decimal, when it is compound interest, it's actually compounded 84 times. So this rounding error affects your answer 84 times. That's why it builds up so quickly and you get such different answers from each other, okay? Other ways to have rounding errors occur in your questions is to simply not store these answers inside of your brackets, your decimal answers inside of your calculator as you go through. So I really encourage you to use the memory function on your calculator as you go through and keep it stored just so you avoid those rounding errors because it costs students a lot of marks in the HSC. Okay, thank you very much.